Hi, 8th graders. This is our 6th and final chapter in our Earth, Moon, and Sun iBook, and it is about tides. Now, tides are something that are really common to people that live along coasts, but we're a little bit out of touch with what tides do here in landlocked Minnesota. Tides only occur, or they're only the gravitational pull of the moon only affects large bodies of water like oceans. We do not have any effective tides in even the largest lakes like the Great Lakes. Okay, so the tide is a daily rise and fall of sea level at any given place on Earth in the ocean. The pull of the moon's gravity on Earth is the primary cause of tides, and the pull of the sun's gravity on Earth is the secondary cause. Now, the sun is a lot bigger than the moon, right? But the moon is so much closer to Earth that it actually has more of an influence on pulling with its gravity, pulling at our Earth. And the rock, right, is really rigid. It doesn't move, it doesn't bend with that pull of gravity, but the water certainly does. It can kind of bulge out away from the Earth on one side, and then on the other side, it kind of shrinks in. And as the moon revolves around the Earth and as the Earth spins on its axis, the location and times of these high and low tides change from day to day. Okay? Some areas have a really big tidal range, meaning a really big difference between high tide and low tide. This picture right here is a place called the Bay of Fundy in Maine, and you can see that this is the same dock here, and it looks like this guy maybe did not pay attention to when the water was going out, when the tide was going to come in and leave. So if he were to walk down to his boat to go fishing, he'd have a lot of difficulty, and he would have to wait until the tide came back in or that water level came back up. Okay, so here in the Bay of Fundy, their tidal range is 38.4 feet. That means that when the tide is high, okay, so when the water comes inland the most, the highest point that it gets to, if you were to put a flag there, and then also mark the place when the water goes out, it flows out, and put a marker there, that distance is 38.4 feet. That's a really big tidal range. The range is the difference between high tide and low tide. There are some areas on Earth that have a much smaller. Most areas have a much smaller tidal range. You go areas around the Gulf or areas around California, they're going to have tidal ranges that are closer to 5-10 feet. Okay. To understand the tides, it is easiest to start with the effect of the moon on Earth. As the moon revolves around our planet, its gravity pulls Earth towards it. Okay, so the moon has gravity and it's pulling the Earth actually towards it. But the lithosphere, the rocky outer area, is unable to move much, right? Rock doesn't really move plastically very easily. The water, however, is pulled by the gravity and a tidal bulge is created. This bulge is the high tide beneath the moon. On the other side of the Earth, opposite of where that bulge is, a high tide is produced where the moon's pull is the weakest. These two water bulges on opposite sides of the Earth are aligned with the moon, are high tides. Okay, so here's a picture of that. The moon is right here. It is going to pull the water away from the Earth, but it's also pulling the Earth a little bit too, which is why we get a high tide over here and a high tide on the side that the moon is at. All right? Where the high tide isn't, you are going to have a decrease in sea level. You are going to have the water level on the shore is going to be way out to sea. Okay, so the water is pulled high here, it's pulled high here, and you're going to have low tide here. Okay, so imagine the Earth continuing to rotate through this. If you are we put an X on the globe, it's going to rotate through one high tide, through a low tide, through another high tide, and through another low tide every day. Every day there is going to be this constant kind of breathing of the ocean. Times where the sea level comes up on shore, and times when the sea level goes out to sea, and then it comes back in, and then it goes back out. Okay, it's a constant thing. It isn't like it just snaps forward and all of a sudden the whole shoreline is flooded. All right, it gradually grows and it gradually recedes. Okay, now how much it grows and how much it recedes is has to do with the moon phases. Okay, so if you think of how the moon and the sun and the earth are set up during a new moon and a full moon, they're right in line, right? You've got the sun, you've got the earth, and you've got the moon during a full moon. During a new moon, you've got the sun, the moon, and the earth. When all three of those bodies are lined up, there's a lot of gravitational pull because now the sun is coming into play as well. And so you're going to have greater tidal range, meaning the water's going to come up further and it's going to go out further during the full moon and the new moon. Okay? And then during the quarter moons, which is halfway between those two phases, you are going to have a lower tidal range. All right, so let me just zoom in here onto the board. I drew some pictures. All right, so what I'm saying here is that at a new moon, we've got the moon pulling at the water of the earth, right? But also the sun is right here as well. And so even though it's a lot further away, it still does have an influence. Okay, so both of these things are pulling at it, meaning the water is going to come way in and it's going to go way out. You're going to have a really great tidal range. Those times with the greatest tidal range happen at new moon and at full moon, and those are called spring tides. It has nothing to do with the season. It just means that they have the greatest tidal range. Now, as we go through our moon phases into the quarter phase, this has a tide of minimum range, meaning there's still a high tide and a low tide twice a day, but it doesn't come up as far and it doesn't go out as far because the only thing really acting on it is the moon at this point, okay? And then it'll increase, it'll come in a little bit further, it'll go out a little bit further, it'll come in a little bit further and out a little bit further until it gets to the new moon where it's a huge tidal range, way out, way in, okay? And then it decreases again until we get to the quarter moon, okay? So I have another diagram here, okay, that kind of corresponds. We have spring tides, they have a great tidal range during the new moon. The spring tides decrease in tidal range until we get to the first quarter. And that is a tide considered, the neap tide has the least or the smallest tidal range. And then the tidal range increases until we get to the full moon, and it decreases until we get to neap tide or the third quarter. Okay, so I've got a couple pictures here that kind of show some of the things that we've been talking about and how they kind of correspond with each other. You know, we've got our moon phases here. We know that a solar eclipse is going to happen here, right? Or a lunar eclipse would happen here in this position. And a solar eclipse would only happen at the new moon position. All right, you've got how the tides grow and shrink in relation to where the moon is. And then also we have our seasons here that I have set up with the northern hemisphere tilted towards the sun right over here and tilted away over here in the winter. All right, we will be reviewing a little bit more. I will take a picture of the board and post that for you because I know that when you pause these videos you have to start over again and I don't want you to have to watch this more than once. And we will be doing a little bit of review and we'll have a little quiz this week about kind of all of this stuff that we've been talking about. All right, I'll talk to you soon.